Green is good. I'm going to pull my notes up. If you guys know me, you know I'm not the most organized person. I'll show you the picture I took of my notes. That's what I'm working off of here. So I scrawled that earlier today, but I forgot the actual picture or the actual paper. But anyway, yeah, my name's Ethan Moore. I work for Stockroom Supply. It's our family business. We're in Wainfleet. If you've never been there, I know a lot of you guys have been there before. But we sell tools and we make tools there. So one of the brands we sell is Record Power. They're out of the UK. We also sell Raycon, which a lot of you guys are familiar with. And we actually do all the warranty and parts service for Raycon across Canada. So that's kind of interesting. As far as the tools that we make, one that I'll use today fairly heavily will be the Little Ripper. So it's just kind of a miniature sawmill for a bandsaw. But yeah, so the thing I want to talk about today in my seminar, obviously, is the bandsaw. I'm going to start with the most frequently asked questions. So the first one that I get asked most often would be how to set up your bandsaw, specifically for cutting straight to eliminate blade drift and all that sort of stuff. And then we'll move on to some other stuff here. But for anyone that's not super familiar with a bandsaw, what I like to do right off the bat is give you kind of a bandsaw tour. And just so everybody's on the same page, we know what we're talking about here. So if we start at the top, bandsaw, you got a wheel on the top here. That's the top wheel. There's also a wheel on the bottom. These wheels on the vast majority of the bandsaws are crowned, so they're slightly round on top. And now that crown is what allows that blade to automatically track to the center and lets you track that blade. That's why they're round on top. As far as the guides, we got side guides here, and we got a thrust bearing at the back. The thrust bearing is what supports the back side, and the side guides, of course, go up against each side of the blade. Below, of course, we got the table here. We got the trunnion that supports the table. That's what makes the table tilt back and forth. And then at the bottom, we have basically a mirror copy of the guides and a bottom wheel. And yeah, so pretty straightforward. The other thing I'll talk about quickly here is the blade itself. So the bandsaw blade, you got the tip of the teeth, obviously the cutting edge, and then you have the back of the blade that we'll talk about. The body of the blade is the approximate center of the blade, and then the gullet of the teeth, that's the lowest part of that tooth. Kind of like you think of an ocean wave, the bottom of the wave is the gullet of the tooth. So we're going to imagine we just bought a bandsaw for the first time, whether you buy it used or new, it's never been set up before, and we're going to start from, I'm going to kind of mess this up right now real quick. We're going to start from a very poorly set up bandsaw, and then we'll go through each thing and do it properly here. That's my tension knob up there, and on the back, I didn't mention this either, there's the adjustment to tilt that wheel back and forth, and that's how you get your tracking there. So when you get the bandsaw for the first time, the best thing to do when you're setting this up is to back all the guides off. So back the side guides off, which I kind of already have done here, and back the thrust bearing off. Now I'm not going to mess with the bottom just because it's the exact same as the top, just to speed things up here. Once you have the guides all loosened up so they're not going to interfere with anything, the first place to start is with aligning the top wheel. Now this might be a little bit difficult for you guys to see, but there's a fairly controversial thing. You can see the front really good with where to position that blade on that wheel, whether you position the body of the blade in the center of the wheel. Some people will say to put the gullet of the teeth in the center. In my experience, it doesn't make much difference, but what I like to do is I always put the body of the blade in the center of the wheel, because if I'm using a wider blade, like 3/4 or more, and you try putting the gullet of the teeth in the center, the back of the blade's hanging over the back of the wheel, which isn't necessarily a good thing. So yeah, first thing you do, line that up in the center, right about there. Okay, once we have that, The next thing that we'll talk about is the bandsaw blade tension right here. So I got fairly low tension on there right now. Now this is something I'm going to show you. It's a method for finding the tension. Now the other thing to know about bandsaw blades is they will pretty much always come with a tension gauge here. Now when you buy a bandsaw blade, this particular saw takes a 95-inch blade. That blade very rarely is made to exactly 95 inches. So if that's plus a quarter inch or minus a quarter inch, that tension gauge becomes fairly inaccurate. So the other thing to talk about with tension is it's a very personal preference thing. There's no real right or wrong answer. Obviously, if you're breaking blades like crazy, you have it too tight, or if it's falling off your wheel, it's too loose. But one thing that you can do, something I never do, but you can use the flutter method. Now the flutter method, what it does is it kind of gives you a baseline of how tight you have it compared to your last time tensioning the blade if you're using the same blade. So first thing you do is loosen it off fairly loose, which I've already done. Make sure the guides aren't touching. We'll close this here, and we're actually going to turn the saw on. And what should happen, see that blade fluttering there? So what we're going to do first is tighten that up until it stops. And then we're going to slowly loosen that again until it starts to flutter. Okay. I don't know if you guys can kind of see that there. It's fluttering away. Now, every 3/8 blades, 3 teeth per inch from this manufacturer is going to flutter at approximately the same tension. So what I do from there is I can do a half turn tighter, a full turn tighter beyond that flutter, and that will give me the same matching tension every time. Do I ever do that? No. What I do is just kind of tighten that up and say that's about good there. But if you want to get really fancy, you could do that. Now the next thing you'll do is adjust the side guides. Now when I say adjust the side guides, I actually mean adjust them this direction here. So this is probably the second most common way that will damage a bandsaw blade is by having these side guides adjusted incorrectly. So when you adjust these, I don't know if we have this. Yeah, this. So if you look right there, you got the gullet of your teeth right there. The back of the side guides should be just behind the gullet, not the back, but the side guides should be just behind the gullet. If you have them set too far forward, let me move this around so you can see. If you have that set too far forward, and you, am I standing right in front? Let's do this. I'll stand behind this. So if you have them set too far forward there, and you're actually hitting the side of the blade, that blade is bent out like this on the front. So if that guide gets towards the tip of the blade, you can shear the cutting edge off really, really quickly. So you got to make sure you have that set just behind the side guides there. I don't know if you can see that in the camera. And then you lock that in place. And you do the same thing on the top and bottom. Now the next thing you do, and this is the most common way that will damage a blade, is the thrust bearing here on the back. Now the thrust bearing, you want set about a paper thickness away from the back of the blade. Now if you accidentally, especially happens on the bottom, I've done it plenty of times before, so you have that thrust bearing set 3/16 or a quarter inch behind the blade. When you start cutting, you'll push that blade back, and when you push that blade back, it'll get into the side guides, and when it gets into the side guides, then you damage the blade. So pay really close attention to that thrust bearing. You don't want it touching, but you want it just behind the blade like I said, a paper thickness or so there. And then finally, the last thing you do is adjust the side guides distance this direction here. And again, paper thickness away from the blade. Lock that in place. And lock that in place. And what you can do is give your wheel a spin. Make sure there's no bearings rubbing, or you'll hear that. It should be fairly quiet when you spin that wheel. And then once you start cutting, that's when you'll hit the guides and whatnot. Go ahead.
What's your opinion on the nylon ones now, the new, rather than the ball bearing ones?
The guides, on the guides themselves? Yeah, so that's a big subject in itself. So there's phenolic is usually what they are. There might be nylon versions as well, but phenolic, and they're usually impregnated with graphite and canvas. They are great because if you accidentally have your guides set up slightly incorrectly and you get those teeth into those plastic guides, the teeth will cut a groove and it won't wreck your blade. Now, the thing about phenolic and ceramic is they're insulators. So when you're cutting, you generally will produce some heat from cutting that wood. So if you have a ball bearing or a steel guide, it actually helps draw heat away from the blade rather than that heat getting trapped in the blade. So blades tend not to break as quickly. So every guide system is good, has good parts and less good parts. So there's no real perfect system out there, but nylon or phenolic guides are a great option. They're probably one of my favorites for sure. So yeah, we got that set up.
Another quick question.
Sure, yeah, go ahead.
So when you set, excuse me, sorry, the side guides front to back is to make sure that they're aligned with the body of the blade?
Correct. Yeah, you want them just behind the gullet so they're supporting the body. Now, when you're using the guides on a blade, I'll talk about this more. Cutting straight, it's less important, but the guides are more important when you're cutting curves and circles. Because technically, if you're cutting perfectly straight, that blade should be straight up and down, not going back and forth. So let's make a quick cut. Make sure everything's cutting properly, and then I'm going to show you something really bad. I shouldn't show you, but it kind of makes a point here. Okay. Oh, I don't have that tight. Should probably tighten that up. So I'm just going to take a slice off the outside here. It's going to be a little thicker at the back because I had this adjusted incorrectly. But let's take a slice off. So it's hard to tell in this first cut. You'll see on the next cut. You can pass that around, but that's a pretty decent cut. Fairly accurate. It's hard to tell because it's a taper, but the actual cut is straight. Everything I just showed you is pretty well the common way you're supposed to set up a bandsaw blade. What would happen if we did everything wrong? So let me get rid of these side guides here. So I'm going to back them off so they're not touching the blade. Okay. So we got no more side guides. Now let's also mess with the top wheel here. So I'm in the center right now. Let's turn this knob on the back. We're going to back that right up. It's not going to sound nice, but we're going to do it. So now we're the tip of my teeth. It's hard to see. Maybe you can see it here. So I'm right towards the back now. where before the body was in the center. Now, remember me talking about that wheel is crowned, it's round on top. One thing that you can read about when it comes to bandsaw setup is if you change the angle of that blade, it'll actually change the angle of your cut very slightly. So by repositioning that blade, some would argue I've actually changed the angle of the blade a little bit because that's on the back of the crown now. So technically, I should be cutting on an angle like this. Now, something to consider with a bandsaw blade is they're approximately twice as wide on the front than the back. So as long as you don't have things skewed out so far that you're hitting the back of the blade, misalignments like that don't really matter. Okay, so we mess with that. The last thing I'll do, let's lower my tension. All right, so we got low tension, we got no guides, we mess with the top wheel. Let's see what happens. Oh, fell off my bearing. It just fell off my back bearing there. I got a little too zealous, overzealous, I mean. But that's okay, we'll pass this around. Until I accidentally fell off that bearing, if you follow that cut along, I'm cutting quite straight. Now, the reason I'm cutting essentially as straight as before, it's really simple, has everything to do with that blade. Now, the most important thing when it comes to cutting straight is actually the blade itself. So you hear me talk about when I'm talking about the side guides there, protecting the teeth. Now, when we're dealing with blade drift or blade wander, if you're familiar with blade drift, basically the blade's going to cut one way, maybe cut another way, go another way there. Essentially what's happening is one side of that blade is duller than the other. Now that may happen because we're freehanding through the blade. That might happen because the guides are rubbing on the side of the blade and we damage the teeth. That might happen because we're using a fence and the piece of wood stresses just like a wood on a table saw. And as that stress hits the side of the blade, it pinches the blade and it makes one side duller than the other. So the most important thing you can do when it comes to cutting straight on your bandsaw, it's less about investing a lot of money into fancy blades or fancy guides, and it's more about protecting the blade itself. So you're always going to want to dedicate a blade to straight cutting. It can be inconvenient taking the blade on and off for cutting curves and straight, but dedicate one blade to resaw, and then do everything you can to keep yourself from binding that blade. So one thing that, if you ask the sawmill operator how they adjust a bandsaw for blade drift, they'll tell you there's no real adjustment on a bandsaw or a sawmill because sawmills don't tend to drift unless they hit a nail or a rock. So what the Little Ripper does is a similar concept where when you put your piece of wood in there, rather than the stress of the wood pinching on here, as I cut my wood, the stress opens up and it never binds the blade, so it allows you to get really accurate cuts over and over and over, even with a very poorly set up bandsaw blade. Yeah, so the next thing I'll talk about, let's just quick questions, will be bandsaw blades themselves. The blade that I'm using here, how much time do I have actually? Oh, you got a question over there.
Yeah. Is there any advantage in keeping the your guide down close to your material, or if you can keep it inches away, what's the best?
I mean, it's certainly better to keep it closer, way safer. If you're cutting straight and you're truly cutting straight, technically it doesn't really matter, but still, it's a good thing to do, no matter what you're doing. Cutting curves, very important. So every time you cut curves, you're going to be hitting those side guides all over here. So on the blade itself, the blade I'm using right now is a 3/8 blade, 3 teeth per inch. Reason I'm using this blade is it's a good blade for cutting straight, but it's also a good blade for cutting circles and curves. Basically, the wider the blade is at the back here, the faster you can cut. Not necessarily the straighter you can cut. You can cut just as straight with a 1/4 inch as you can with a 3/4 inch wide blade, but a 3/4 wide blade has a lot more meat behind it, so you can push harder on it without it deflecting. So the wider the blade, faster you can cut. The smaller the blade is, the sharper curves you can cut. The finer a blade is, so the more teeth there are per inch, the smoother the cut. The fewer teeth per inch there are, the more aggressive, the better chip clearance you get, so less likely to get burns. I tend to use a more aggressive blade than some, just because it clears the chips a lot better. And I tend to cut a lot of green wood, and on green wood, the bandsaw blades like to bung up a little bit easier. So of course our blade's a little bit better on that. And then the other thing I'll talk about too, on bandsaw blades, there's different materials that you can get. There will be Swedish silicon, industrial carbon. The blade that I have here is a carbon blade. Essentially, a Swedish silicon blade is a little bit of a finer metal. They can sharpen them sharper. So they're a smoother cutting blade, where a carbon blade is a little bit of a tougher material. So they tend to stay sharper for longer through abrasive materials, so like bark and cedar and things like that. That has like high silica content. So Swedish silicon blade, they're really nice for cutting veneers off of like kiln dried piece of wood and exotics and things like that, where carbon blades are a little nicer for rough cuts and things like that. Yeah, any questions on blades at all, or go ahead.
Is it beneficial to send blades in to get them sharpened, or just replace them, or?
I mean, there's very few places that'll sharpen bandsaw blades. Some guys like to sharpen them themselves. It is monotonous and time consuming. But the other thing to consider on a bandsaw blade, unless we're talking carbide blades, they're a little bit different. But the hard metal, it's almost like got a hard coating on the outside. So once you sharpen it, you remove some of the harder coating. And then once you get to the inside, it's softer, it doesn't last as long. So they wear out even quicker. So generally it's not worth, like a bandsaw blade's 20 to 25 bucks. Generally it's not worth sharpening, but if you have a carbide blade, it's a little bit different because they're big money and they can be sharpened a little bit easier.
And what's the best scenario for using carbide blade as opposed to these?
Carbide blade, they're like $250 for a blade, but they cut as smooth as a table saw blade would be. So the cuts I'm making are, while they may be straight, they're fairly rough, so you'd have to sand that once you're done. Carbide blade, it'd be just like a table saw basically. Challenge with a carbide blade is they're very thin curve. They don't do a very good job of removing chips throughout the cut. So if your wood is wet at all, they get bunged up and they don't work very good. So they're really only used for really nicely kiln dried chunks, usually expensive wood that I want to get a nice fine veneer out of. Yeah. Any other questions? Go ahead, Don.
Your little ripper you're using because it supports the wood properly, and when it goes through, it stays nice and straight. When you run it by a fence, it relieves the stress on the wood, and then it pinches on the back end of the blade.
Yeah.
Because you have an adjustable fence, if you bring the back end of the fence
That's a good point, yeah.
up
Like
to
this.
the center of the blade, you don't get that pinch.
Yeah, so that's absolutely the best way to use a fence right there. So if you back, some people call it the European way. Basically, you end the fence at the back of the blade, so that stress in the wood can open up and do whatever it wants there. Now, things to consider if you want to get really excited: a bandsaw blade's only got about 25 thou set in the front. They're fairly thin. They're quite fragile. If I remove one thou from either side of that blade by pinching it, it's going to cut 7 or 8% better the opposite way. So what you'll see if you watch YouTube videos, when guys are resawing, just about every single time, the piece that they're resawing on that video is nicely jointed and square, so that when they put it on their bandsaw table, it's not going to rock. Because when that rocks, just like that, that's another way that you can bind your blade, just from pinching it like that there. So, I mean, that's another small advantage to doing it with a carriage, whether you make it yourself or you buy one, is when you put it in the carriage, you don't have to worry about it being flat, or it could be a log or a burl or whatever you want, and it still won't bind the blade. Yeah. Okay. How much time do I have?
You are 20 minutes.
Oh, wow. I flew through that. Okay. Great. So the other thing
No, you have 20 left.
I have 20 left. Oh, okay.
22.
Okay. The other thing I'll show you guys, a totally different way to set up your bandsaw blades if you want to cut curves. Now, a standard curve where I don't have anything here, but say you're cutting a duck decoy and you have a pattern and you want to follow that pattern, the setup I just showed you is the proper way, because that's going to give you the ability to follow a line really easy. Now, I know you guys are going to be talking about bandsaw boxes a little bit after this, and one really cool way you can set this up, especially for bandsaw boxes, is kind of more of a free flowing setup here. So what we're going to do, let me bring this. Oh, that's what happened. It fell right off my wheel at the top. I wondered what happened. If you look at that, it's right off the back there. I thought it fell off that bearing, but no, it fell off up there. Like I said, I got a little too excited. Okay, let's see if we can get this back. All right. Back on there. There we go. All right, so we'll bring that wheel blade back to the center. So when you're setting it up to free form curves, what we're going to do is we're going to back these side guides up. So the very, very back of the blade, like the last 16th of an inch, those side guides are beside. Okay, so just at the very, very back. And after, you can come up and look and see what I mean here. Lock it up at the very back. You're going to bring that thrust bearing up to the back of the blade, and you're actually going to push a little bit of pressure on that blade so it's touching that thrust bearing. So essentially, what we've just done is the very back of that blade is supported. But now that blade can tip back and forth like that at the front, but it's supported at the back. So not very good, pretty lousy for trying to follow a line, because it's not going to be controllable. But what that lets you do is that blade kind of cuts just sort of the way it wants to cut, makes nice free forming curves. So if you're making a bandsaw box that maybe doesn't have a pattern and you want some nice gentle curves, that's a really cool way to do it there, just by supporting the back of the blade.
Do you do both top and bottom?
Same thing on top and the bottom. Some people would even only do it on the top. and leave the bottom guides not even touching. But I would do it on the top and bottom.
It's like the Carter guides they're selling,
Yep.
only the one blade on top with the blade running
Exactly.
through bearing.
Yep, the Carter stabilizer. That's, I mean, basically what I did, just with some unique setup, you just made a Carter stabilizer right there, just by setting up your guides a little bit different. Yeah, so that's another kind of neat way you can adjust them if you are doing curves. Not the best way necessarily to cut straight or following a line, but it's another interesting thing. The other thing I'll talk about real quick, since we have time, is setting it up to cut circles. I guess I should, it'll be fine the way it is.
While you're doing that, Ethan, on the back of my Rikon and also on the back of this record power, there is the tension release lever.
Yes,
There
right
is a
here.
debate up higher. There is a debate about whether or not when you leave your shop after using your bandsaw, you should release the pressure on your blade and wheel. What's your theory?
I think it's a great idea. The idea is if you don't release the tension when you leave your shop and that blade is staying tensioned for a long period of time, when you go to use that saw, that blade is more likely to break, especially at the weld. But if you lower the tension every time you're not using it, that blade's just generally going to last longer. So especially if your saw has a lever like that, it's a quick and easy, simple thing to do, and your blades probably will last longer. I don't know if anyone's actually done studies on it, but it kind of makes sense.
Does that have a lot to do with the tire, your type of tire you're using as well?
As far as the tension part of it, like the tires basically do almost one thing, and they protect the inside teeth of your blade. So the tires right here, that's the yellow on the wheels here. If you didn't have tires and that blade was right up against that cast iron wheel, the teeth on that cast wheel would bend flat, and when they bend flat, that blade would cut better away. It would drift like crazy. So having those tires there is really important to keep that from happening. Now, as the tires wear or age, they will harden. And eventually they get so hard, they're nearly as hard as the steel, and they don't do a very good job of protecting your blade. So if you notice any cracks or your tires are really hard in your machine, it's definitely a good idea to replace them, because your blades are probably going to get damaged even just from the tire there too. Yeah, so cutting a circle, unless there's other questions quick, I can answer them. But this right here is another jig that we make called a simple circle cutter. It's pretty simple. Let me move this out of the way. How are we doing on time? We got 10 minutes left or so?
You've got, let's say, 15.
Okay. So when we're setting up to cut a circle, you're never going to use a blade any wider than a 3/8 generally. If I had a 1/2-inch blade on there, the smallest circle I'd be able to cut is like 12 inches maybe. So if we're cutting a circle, you're going to want a 3/8 or less. But when you're setting it up, you want the pivot point of your circle to be in line with the tip of the teeth of your blade. Now this could be a little bit deceiving sometimes, and it's especially important on thicker wood here, if you're cutting like a bowl blank. If you have, again, a space between your thrust bearing and the back of the blade, and when you start cutting, you're actually changing, you may change the position of that blade. So you got to make sure when you're setting up to cut a circle, you have that thrust bearing set up correctly, or it might cut a spiral rather than a circle. So what I'll do is I'll quickly adjust this. So I have it in the center. I've got a line actually right on this jig that gives me right in the center of my pivot point. So I'll lock that in. Now on this particular jig, comes with a little pivot point like this, but you can make a nail through a piece of wood. Same idea. That's got a little screw on it, and then this collar just fits into my circle cutting jig, and that's how I can position it for different diameter circles. And then you got fine adjustment here in the miter track. But what I'll do, I'll cut just a little bit off it right there. Oh, that's the same diameter as last time. So that stop here is set. I'll move this back here. There we go. Well, I didn't adjust these yet, did I? Putting everything back the way it's supposed to be. So when you're making yourself a circle cutter, you want to have a stop so that when you push this in, it'll hit that stop. So it's pretty straightforward. But the only thing you really got to worry about is having that pivot point right at the tip of the teeth, and you got to have a solid stop position there when you are cutting a circle. Yeah. Now the other things I can talk about are the inserts. Now a lot of you guys would be pretty familiar with inserts anyway, but I'll pass around a few different things. Most bandsaws will come with this right here. That's so you can pass that around, I guess. Where they'll have holes in the insert and a slot for the bandsaw blade. Other options that you can get will be zero clearance inserts. So these have no holes or no slot, and the idea is you will cut a slot with your blade so there's nowhere for little chunks to fall in. And if you have a little chunk fall in, that's another way you can kind of wreck a blade. Now another kind of interesting insert that we're making is this right here. This is an insert that has guides built in. So that's called a blade lock insert, and that's got those phenolic guides. So they're meant to have guides directly below or directly at your table, so directly below where your wood is cutting. So it gets your guides as close as possible. Now there's a cool thing about phenolic guides or any block guide is when you're cutting wet wood, they help keep the blade clean, where you can imagine you have roller guides, bearings on there, and you have those bearings on the bottom. As sawdust falls through there, especially if it's wet, those bearings act a bit like rolling pins, and they'll push the sawdust up into the side of the blade, and you'll notice that you get some buildup on your blade, and that'll get wider and wider, and you need to clean it off, or eventually the back of that blade will be wider than the front, and it won't cut. So using block guides, whether they're steel guides or phenolic, they help keep the blade a lot cleaner, especially important when you're dealing with wet wood.
What would you say is the ideal blade size if you want to cut, if you're trying to drop that table on a 45 and cut those circles on a 45?
How big a circle? Like how thick a wood I meant to ask?
Oh, just 3/4, 1 inch.
So another rule of thumb, you should always have at least 3 teeth in the wood at a time. So if your piece is, say your piece is 1 inch thick, the coarsest blade I would be able to use in here is about a 3 TPI blade. Now, when they measure a blade, I should mention this too. The width is measured from the tip of the tooth to the back of the blade. The teeth, TPI, is measured how many teeth fit in an inch. So if you got 3 teeth in that inch, it's 3 TPI. You always should have at least 3 teeth in your wood at a time. If you don't, you get major tear out. So if you're dealing with something 3/4 of an inch, the coarsest blade you could have is about a 4 TPI blade. There's no real right or wrong blade. It's kind of a personal preference thing.
Would you go to a wider blade or a thinner blade?
How big a diameter are the circles?
Say it's the size of that, like 12 inches.
Yeah, I would probably go with like a 3/8 blade, 4 or 6 TPI. That'll give you, that's probably it's a good run of the mill. It does a little bit of everything. The biggest blade you could possibly use is 1/2 inch, but you're not going to gain anything necessarily by using a wider 1/2 inch blade compared to the 3/8. Any other questions? Go ahead.
Yeah, so for this insert that
Yeah.
has the 2 guides, do they adjust inward?
Yes. Yeah, I can take it right out so you guys can play with it a little bit more here. So they slide back and forth like that.
And that way you can make it kind of zero clear.
Yeah, then you're exactly right. It kind of acts a bit like a zero clearance insert as well. Yeah.
Those, circle the black ones. What's the best way to cut that groove?
That's a good question. It can be a tricky thing, honestly. The way I do it is honestly, I use a hacksaw and I get it really close. And then at the very end, I just cut the last little bit. But yeah, it can be a little precarious because you want to cut it and then it falls in the hole. So the way I've done it is just with a hacksaw, just to get me really close and then just do the last little bit.
I just made a jig for mine to sit in the track, so the insert fits in that.
Yeah.
And just take it to the bandsaw, and I've got the exact same cut as the bandsaw.
Beautiful, yeah. And then you just have the jig, and so it's perfectly aligned with that center hole. Yeah, that would work really good. Yeah, awesome. What else was I going to show you? Oh, the other new product that I'll show you here. Now this is more commonly used on a table saw, but this is a new little crosscut sled that we're making. Put this in here. So basically it's a sliding table that'll attach to any machine, including a bandsaw or a shaper or a table saw. You use whatever miter gauge you already own. So it's got a 3/4 by 3/8 slot in the center. It doesn't come with a miter gauge, but most guys already own one. But yeah, it's just a far more affordable sliding table. If you guys have seen sliding table saws before, they can be very expensive. So that's kind of a neat little thing. Any other questions there?
Ethan, the back thrust bearing, I've noticed some bandsaws, it's this way as opposed to what is there.
Yeah, so
Preference?
there's good and bad things out of both styles. So a bearing that is this direction, which is what the saw has right now, somewhere on this bandsaw blade, there's going to be a weld. I don't know where it is, but oftentimes on that weld, there can be a little burr at the back or a little imperfection where they put those blades together. And if your thrust bearing looks like that, maybe we'll listen. We'll see if we can hear it. If your blade has an imperfection, when it goes to that thrust bearing, it'll go tick, 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 right? And you can see sometimes that tick right in your cut if the blade's bad enough. So that's why a lot of guys will go and file the back of the blade to make sure that it runs nice and consistent against your bearing. Now, if you have a bearing that's oriented this direction and it rolls along there like that, if you have an imperfection in the back of the blade, it's far less apparent because that bearing will kind of roll right over top. That all being said, when your bearing is set this direction, it gives you maybe just a little bit more support compared to having just one point. You have 2 points or more along the back there. So yeah, now if your bearing is set this direction, if it doesn't have a cap on it, they'll wear out really fast. Where this one has a cap on it, which is pretty helpful for that as well.
So it has which on it?
A cap, like a cap on the bearing,
Oh,
and that kind of seals it from
okay.
dust and grime getting in there. Yeah, any other questions?
Okay, this is break time, so you can actually go up and take a look at the record power. I think you should take a look at some of these special devices that Stockroom Supply has created. The little ripper, the circle cutter, they're amazing. And it gives you a chance to get up close and talk to Ethan. It'll take 10 minutes. And then we're going to go to 3 of our club members on bandsaw boxes and end with a presentation also on the large sawmill. So 10-minute break, refreshments, questions. Thank you, Ethan.
Thank you. Good.